welcome back. So we are on part 5, starting at number 25. And these are the first problems that talk about exponents and logs. And on the first grouping of problems, all we have to do is convert from a logarithmic equation to an exponential equation, or an exponential equation to a logarithmic equation. That's the first step. Now, if you notice at the bottom of this section, it says, after converting the 12 problems above, they can now be solved for x more easily. Solve the problems above for x. Do not approximate your answer. Work out your solutions on a separate piece of paper. So this is serving as my piece of paper, so that's great. And I'm just going to go ahead and do all of that. So I'll convert it and solve it. All right, so I'll write down number 25. So we've got x within a log, and what we need to do is get it out of the log to where it just says x equals something, right? So what we want to do is we want to convert. You want to make the log go away, and you do that by doing this conversion to an exponential function based on this relationship between logarithmic functions and exponential functions. They're like inverses of each other. So the way you convert is you take the base of your log raised to this power. Again, it's an exponential function is what you want to convert to. So it has an exponent, and that's 3 in this case. And it equals this right here, the 3x. So what that looks like is 4 to the third equals 3x. And now you just divide by 3 to get x by itself. And so x will equal 4 to the third over 3. Right? Very good. So moving on to number 26. We've got log of the quantity 10x minus 1 equals 1. Now, you might be thinking, well, what is the base? I don't see a number down there. And you are quite right, there's not a number down there. But this is an extra piece of knowledge you'll need, and that is that this is called common log. When you just see log by itself, that is called common log. And common log has a base of 10. This right here, this bit of info, is going to show up on your final. And it's just going to say, what is the base of common log? And all you need to put is 10. That's one problem on the final that you'll get the answer to. All right, so the base is 10, and you convert it just like we did over here. The base raised to the power of the answer here equals what you're taking the log of. So that is 10 to the first power equals this whole thing, 10x minus 1. So that's what we do. 10 to the first equals 10x minus 1. Now, I'm going to keep working these problems out in such a way that is generalized so that we don't know what 10 is, or maybe it's some difficult number and you might need a calculator for it. Don't worry about it. Just leave it like it is and keep working the problem out. So here you got to add 1, and you're going to get 10 plus 1 equals 10x, and then you just divide by 10. And you get x is equal to 10 plus 1 over 10. All right, there's your answer. All right, moving on to number 27. You've got the natural log. Ooh, what is natural log? Of negative 6x quantity equals e. So this is another thing that's going to show up on your final, and that is to know what this is. And it's natural log, and it has a base of e, the constant e. So this is really log base e, right? So that's something important, log base e. So I'm going to rewrite it as log base e of negative 6x equals e. And you want to convert this as the base raised to this power equals this, and so that's 6. That is not a 6, it's tricking me, that's an e. It's my handwriting being bad. So it's e to the e equals negative 6x. We have e to the e. That's so complicated. Yeah, I don't have any words for you. All right, so here you want to get the x by itself. So you want to divide by negative 6, divide by negative 6, and you get that x is equal to negative e to the e over 6. The negative sign can be brought on the numerator if you want, or the denominator if you want, or the whole fraction. I don't really care where it goes. All right, so there we go. Moving on to number 28. This is going to be a long section, so be prepared. So 28 is, our first problem that starts in exponential form. 3 to the 5x equals 91. So what we want to do is we want to go backwards. To solve for a variable that is in the exponent, you need to convert it to a log. Right? If you notice, when your problem is in log form and your variable is buried inside the log, converting to exponential form leaves it out in the open, right? It exposes it, which is good. That's how you want to isolate it. On the reverse side, if your variable is in the exponent, having to solve this problem, you'd have to think like, you're going to multiply 3 by itself some number of times, and it needs to give you 91. And that number of times needs to be 5 times some quantity that's unknown. So this is already complicated. So to make it less complicated, you want to expose this x to make it easier to solve for, like we did up here. You want to convert it to a log equation. And to do that, think back up here. All right, so we had this 4 came from here. It was the base. So it's going to be the base again. So you've got log, and the base is going to be 3, right? The base, it's here, became the base. Right? So the base becomes the base. It's pretty easy to recognize here. And then say you're confused and you're thinking, I don't know what goes where from this point. Well, remember, if you're going backwards, you would take the 3 and raise it to this power, and it gives you the answer. So this is to this power, right? So the power is what goes here, and this happens to be the power. So the 5x goes here, and then the remaining spot, 91, goes here. Right? This is the conversion. And now, look, the x is exposed. All you need to do to solve for it is to divide by 5. And that's what we'll be doing. So you want to divide both sides by 5. And you're going to get that x equals log base 3 of 91 over 5. And that is as simple as, that's as simplified as I want you to get. Your calculator can give you some decimal approximation for that, but I'm not interested in that. Right. Moving on to number 29. Hopefully that is also a 9, and I won't hear anything else. So 9 to the 1/2 x. That looks like 1 over 2x, but it is not. It is 1/2 x power equals 16. Now, don't let this confuse you. Like a fraction in an exponent with a variable, I'm going to cry a river. Don't worry about it. So just convert it to a log, exactly like we had been doing. You take this, and it becomes the base. First things first. Let's do that. Log, this becomes the base 9. Then notice the answer here. Right, this answer moved right here. So that's what's going to happen again. So this answer is going to move right here. And you're taking log base 9 of 16, and it's going to equal the exponent. So the exponent will move out, just like this exponent moved out in front here. It's going to move out again, so it'll be 1/2 x. And now is an appropriate time, if you are afraid of fractions, to start being concerned and start having panic attack, how to deal with a fraction. You can pause the video and have one now, and then I'll explain how to solve it. Okay, so what you want to do is think of dividing by 5 up here. If you just want to divide by a half, you can. But dividing by a fraction is the same as multiplying by the reciprocal. So if you were taking something and dividing it by another fraction, it's the same as multiplying by the reciprocal. So 1/2 divided by 1/2 is 1/2 times the reciprocal of a half down here, which is 2/1. And that is multiply straight across. That's 2/2, and that's 1. All right. So instead of dividing by a half, let's look at multiplying by 2/1, which is 2. So that's what I'll write it as. Right? If I had multiplied, all right, so scratch this. If I had multiplied by 2 instead, right, the concept is the same over here. Right? This is an alternate way to think about it. If I multiply by 2, a half times 2 is 1, which is exactly the same as canceling. It's not always necessary to divide by this number in order to cancel. The whole point is to get x by itself, which means just to get rid of the 1/2. And there's lots of ways to do that. And another way is just to be multiplying by 2. Don't think of it as multiplying by the reciprocal if you don't want to. Just think of it as multiplying a half by 2 creates 1, and that's what you want. You want 1x. So you've got 2 log base 9 of 16 equals x. And there you have it. Also, just as a point out, the little quips I make, the jokes, they're not for you. They're to entertain me while I do all this work for you. I just want to be real clear about that. All right. So number 30 is 18. Think of it as something you just have to bear. It's the burden you have to bear to watch me do all these problems. 18 to the 2x plus 3 power equals 5. Now this is a situation, this is the first time that multiple terms have been in the exponent. But that's not going to change what we do. The variable is in the exponent. To get it out of the exponent, you convert to a log. And that's what we're going to do. So again, you've got log, and the base is this base here, 18. And look, the answer goes here, so it'd be 5 equals 2x plus 3. Alright, so ignore all this stuff. Just look over here. Look at the 2 steps that are necessary to get x by itself. You'd have to subtract 3 and then divide by 2. That's all you do. Regardless of what this is, you're just going to subtract 3 from it and then divide it all by 2. Right? So let's do that. So we want to subtract 3. Now this is not log base 18 of 2, right? This whole thing is a single quantity. That's like a single number. So it's that number minus 3. Right? So that's the way you got to think about it. So it's log base 18 of 5 minus 3 equals 2x. And now you just divide by 2. And you're going to get x is equal to log base 18 of 5 minus 3 over 2, all over 2. All right, there's number 30. And to any of you still watching this, you all are troopers. I really dig your work ethic. Number 31. Log base 3 of the quantity 5x minus 2 equals 6. Alright, well, we're back to a log. This one's simpler for most students. You convert like this and write that down. Something I want to point out though, all of the problems on the review are written in this format, where it's the log equaling something. On the latest practice sheet, there was a log problem where it was written like this. And students just totally lost their mind. They had no idea what to do. They're like, oh, but I take 3, but there's nothing over here. I don't understand what to put. Well, yes, yeah, that's right. because it's over here, right? It's it's 3 to the 6th, regardless of which way you go. It's the base raised to the answer. Right? The answer's over here on this problem, but it's over here on this one. Right? Just to point that out. Right? So this is 3 to the 6th equals 5x minus 2. And again, don't worry about this. Just add the 2 and divide by the 5. So you want to add the 2, and then you want to divide by the 5. So you've got 5x on one side and 3 to the 6th plus 2. Then you divide by 5, and you get x equals 3 to the 6th plus 2 over 5, all over 5. All right, there we go. Number 32. This is going to go to 36, by the way. Number 32. Log base 11 of x equals 2. Super, super straightforward here. It's just one conversion and you're done. 11 to the 2nd equals x. And that's it. 11 to the 2nd equals x. Wow. Easy peasy. 33. 10 to the 8x equals 7. So here, we start as an exponent. Variable is in the exponent. That's a problem. So you need to make a log. The base of the log is the base of your exponent, which is 10. And then the answer goes here, and it equals 8x. So now, the one step you need to do to solve for x is, that's right, divide by 7. Good job, kids. 7. No, 8. Well, you were totally wrong, kid. It was not dividing by 7. It's dividing by 8. So, you get x equals log base 10. I'm not even going to write the base 10 because log base 10 is just common log. No need to write the base. Log of 7 over 8. Awesome. Number 33 is done. It was going to bother me to not do that, so. All right, let's do number 34. Number 34 is 21 raised to the 8x plus 4 power equals 80. Now these have bigger numbers in them. This is a situation in which you don't want to try to start thinking through these logs. So convert. Log base 21 of 80 equals 8x plus 4. And I did that quickly, but if you want to check, try to convert back. This way is always easier for students. 21 to this power is equal to this. Is that right? 21 to this power equals this. Yeah, it's exactly right. So that's good. So now we want to get x by itself, and so you have to subtract 4 and then divide by 8. So you want to subtract 4 and then divide by 8. So you want to subtract 4, and then you want to divide by 8. So you're going to get 8x over here equals, and then you got log base 21 of 80 minus 4. And you divide by 8, and you're going to get x equals log base 21 of 80 minus 4 all over 8. Beautiful. What a beautiful problem. 35. Natural log of 11x is equal to 9. Those parentheses, not necessary. Again, natural log. This is really log base e of 11x equals 9. All right. So that would be, if you were to convert it, it'd be e to the 9th power equals 11x. So that's what we're going to write. E to the 9th power equals 11x. Divide by 11, and you've got x equaling e to the 9th over 11. Good job. And lastly, number 36. I put myself in a box, I've got to complete it in this amount of space. So you've got 6 to the 3x plus 1 power equaling 4. Convert it to a log again. Log base 6 of 4 equals 3x plus 1. So you're going to subtract 1 and divide by 3. So this is the subtracting 1 bit. So there's my minus 1. I subtracted 1. And now I'm going to divide by 3. There you have it. Hopefully you have learned something or got a confidence booster in these problems. Please join me next time for numbers 37 through 41.